In this question from the increasing, decreasing, we have to find the interval. This is the function. We have to find the interval on which this function is increasing or decreasing. So if I write on the function, this is fx is equal to log 1 plus x minus 2x over 2 plus x. Now, before we find the derivative, let's find the domain of this function. You can see that for log, the function inside the log has to be greater than 0. That's the first condition. The second, we should know that it's in the form of p by q, where q cannot be 0. So 2 plus x cannot be 0, implies x cannot be minus 2. Now let's find its derivative. If we find its derivative, f dash x, log x derivative is 1 by x minus, keeping 2 outside, if I apply quotient rule, x derivative is 1 times 2 plus x, that is v here, minus, say, x being as it is and its denominator derivative is 1 divided by 2 plus x whole square. Now I can see that if I open this bracket, this and minus x get cancelled. So what we are getting is f dash x is 1 over 1 plus x minus 2 into 2, that is 4 over 2 plus x whole square. Next, I'm taking LCM here. On taking LCM, this is 1 plus x multiplied by 2 plus x whole square. Now, if I write this to 1 multiplied by this, and on expanding, we are getting a square plus 2ab plus b square, and minus 4 multiplied by this should give you, when I multiplied minus 4 with this, should give you minus 4 minus 4x. Now we can see that minus 4x plus 4x get cancelled. There is an x square, a plus b whole square, right? It was x square. Now this plus 4 and minus 4 also get cancelled. And writing in the simplified form, we get f dash x as, this is, I'm separating 1 over 1 plus x and into, this is x over 2 plus x whole square. Actually, what I did, I wrote square term together and the other term together. Now, we have to find the interval on which the function is increasing, and the two conditions we have already got this. So for functions to be increasing, we know that f dash x has to be greater than 0. Now check when this can be greater than 0. First condition, we know that x has to be, from here, we can say x has to be greater than minus 1. And the second is that over here, like say over here, we can say that 1 over 1 plus x will be greater than, this is this is what, 1 plus 1 over x has to be greater than 0. But then first of all, I need to say that, let's talk about this one. This is a square function, right? This is a square function. So this will automatically always be a positive number. So therefore, the function, whether it's an increasing or decreasing, relies on this 1 over 1 plus x. And that is what has to be greater than 0. Now, this cannot be, as you know, that inequality will not occur if I take x is equal to 0. So we can say that the condition is x is not equal to 0, but greater than minus 1. So we can say that for the function will be increasing from greater than minus 1, that means open interval minus 1 to 0, right? To 0, because it cannot take 0, open interval, union 0 to any number which is greater than minus 1, but not 0, that is 0 to infinity.